Hello, thank you for joining first of all, and glad to see you in a big number here. Let's start the talk. It's going to be about building hyperfast APIs using gRPC. But first, let's introduce ourselves and let's start. So, my name is Ștefan Dascălu. I'm a team lead in ING Hubs Romania, which is a software delivery center for the ING group. We are delivering software for the entire bank, not only for the local bank here in Romania. I mostly code in Java and Kotlin, but sometimes I also code in JavaScript. And because I'm working on a project where performance is key, I always try to advocate for trying to see new technologies and trying to basically use new technology to solve problems that you might encounter during your projects. And because of that, I'm very passionate about trying new frameworks, and that's what this talk is going to be about, how we can solve a certain problem using a certain type of framework. It's going to be a practical approach about how we can leverage gRPC in order to achieve high-performant APIs, which also provide availability and consistency. And what I would like to ask you is to keep in mind the fact that today, basically, we are building the software that is going to be considered as legacy tomorrow. And because of that, I think it's very important to actually build it as good as possible from the beginning. And because of that, let's keep in mind that we want to see software and to build software that is scalable, elastic, message-driven, and responsive. In a word, we are trying to build a reactive system so that we can use it as long as possible. In order to start the talk, we are going to look at JSON and REST APIs. And for this, let's see here how JSON looks. So we can see that JSON is a clear way of defining a message. You have a clear structure. It's not as verbose as XML, and as you may know, it's the default way of exposing data for REST APIs and for microservices these days. It's very easy to debug. It's very easy for a human to actually understand it and for developers to work with it. In a JVM world, we have a lot of serializers and deserializers that we can use in order to actually deserialize this, and this is why it's very popular, and this is why we are using it a lot. Moving forward, looking a little bit at REST, we can see that it uses this JSON in order to communicate with the client, and the HTTP protocol together with all its verbs in order to actually deliver the messages. Looking here, we can see that what REST actually does, it provides a state machine which allows us to see exactly what are the resources and what are the states of those resources. Basically, we can see the life cycle of each resource. We can, of course, get all the resources, save them, or even update them. But as such, REST cannot be used. And because of that, we are going to look at what Roy Fielding actually said in his thesis. We see that a resource is not actually a mapping to a set of to a single entity. It's actually a mapping to a set of entities, not the entity that corresponds to the mapping at any particular point in time. And because of that, looking forward, we can see here two new endpoints, which actually are using multiple resources behind the scenes, and not only one or one entity from the database. It's actually using more than that. You can see, for example, here in blue, like a long-running task, which might not even give immediate feedback to the user, and actually does something for us behind the scenes. Moving forward, we can see for REST that is one of the most widely used in the industry. But let's see how we can improve it, and let's see how we can actually use other things in order to improve our software. I propose to you to actually start looking at Protobufs and gRPC, and for that, let's start from Protobufs. We started with JSON, which was the message that actually is being used for communication with REST services. Protobuf is the message that is being used for gRPC communication. It was invented by Google, and as you can see here, it has a clear structure. For those of you that work with Kafka or with Avro, you can see that here we have like a schema definition. We have exactly what are the types of each fields, and also an order of those fields. That order is very important, because this schema is actually being shared between the client and the server. And because it's being shared, it is a strong contract, it's a binding contract that actually you have between them. And because of that, we also have a lot of advantages. You can actually start doing the development even before the server actually the producer of the data actually finish the development. Because having the message, you can actually start mocking everything. You know that this is the message, and you know that this is going to stay and is going to be the final message. Because of that, of course, you also have some issues. Because if you want to add a new field, it's very easy. You just add it at the end, and that's it. But actually, if you want to update or delete a field, you have a problem because you break the contract. So then what's going the client to do? It will have a problem. It will not be able to understand that message. Imagine that you deleted, for example, this message, departure time, and then you replaced it with something else, which is not a string, but it's a double. When he will try to parse it, he will have a problem. So that is not okay. As you can see, it's not as flexible as JSON. In JSON, you can actually define everything, and it's very dynamic. But what is then the advantage of using Protobuf? The main advantage is the fact that it's being serialized as a byte array. As you can see, being serialized as a byte array, we actually obtain better performance because then you can have smaller messages which are serialized in this byte array form, and then they are being sent across the wires over the client. Now, in order to achieve the best performance, you need to have small messages around 1 megabyte. But of course, you can also obtain some performance if you have messages up to 64 megabytes, and the hard limit imposed is around 2 gigabytes. So yeah, you cannot go over that limit. It's a hard limit that was imposed. Moving forward, let's look at gRPC, the subject of our talk. gRPC stands for Google Remote Procedure Call, and as you can see, it's actually a different paradigm of implementing APIs. It's not like REST, it's remote procedure call. And because of that, basically what it does is that we as a client, we are actually executing some code on another server, which might be closer to the data or might be better performant. Maybe it has more computational power. Looking a little bit, we can see that actually it's using a proto-compiler, which basically interprets the message that we saw earlier, where we can see the request and the responses. And also, in the lower part of the presentation, we also had like a service. I think it's pretty hard for you guys to see it from the back. But also we are going to see it later in the live coding session. We also have a service implementation. Once the proto-compiler runs, it's going to generate both for the client and the server, it's going to generate the stubs that we can use, either to actually call the server here or actually implement the APIs. So our code is already prepared beforehand. We just need to override some methods, implement them, and that's it. We actually implemented our API. Because as we saw earlier, the message is a byte array, it's also pretty fast to use, to send it from the server towards the client, because we are also using an HTTP2 channel. HTTP2 offers multiplexing out of the box. So basically, you can send as many requests as you want, and you are going to get back the responses in the same order as you made the requests. And this is one of the most important things that gRPC actually has to offer. Moving a little bit forward, let's talk about when we can actually use gRPC. So gRPC makes gRPC makes a perfect fit in polyglot environments, because actually you have a lot of plugins that can be used in order to generate C++ code, Rust code, Golang code, or even JavaScript. And of course, in the JVM world, you can generate for Java, for Kotlin, for whatever you like. Also, it offers a very important feature, which is called bi-directional channels. Basically, you open from the beginning an HTTP2 channel, that connection stays alive, and you can send requests and receive responses on it. This is very important because then you can implement low latency application with high throughput, and of course, also real-time applications. You can imagine something like a chat, or let's imagine that you have a trader which is discussing with the risk manager, and then he needs to get some data from him, some feedback, like, okay, I have this trade, please give me the P&L or something like that, in order to be able to decide if I actually want to book that trade or not. And of course, it makes a perfect fit in microservice environment. This is because we have this bidirectional channel, and because if you have microservices which have a lot of noise and they talk a lot between them, then actually you could also achieve event-driven architecture, because you can just send a request, the server is going to process it when it has some time, it's going to send back the request, so on and so forth. It's very important for microservices communication nowadays. So let's look a little bit at how it can actually be used with reactive streams. This is very interesting from a gRPC standpoint, because actually we have the HTTP2 channel, which has its own flow control that is being used for reactive. And now what I would like you to, what I propose to is to actually consider that we have a database which is also reactive, so something like Redis, which offers a reactive driver. And let's see exactly how a call from a client towards a server would look like, and how the response is going to be sent back. So starting from the consumer side, we actually imagine that we want to request something from the database, let's say some stock prices. What I'm going to do is that, okay, I know my indexes, and I want for those indexes to actually get back my stock price. So I'm going to create a list of the indexes that I want to send to the server. I'm going to create it using a reactive stream, let's say a Flux. In this situation, we are using the reactor implementation. That reactor implementation can be consumed, that Flux can be consumed by a stream observer from gRPC. Stream observer is actually an implementation on top HTTP2, which actually is able to receive data, do something with it for each message that we are sending, and then basically putting it on the HTTP2 channel. Once it reaches the HTTP2 channel, each message is being sent in order towards the server. On the server side, what actually happens is that the stream observer that we have on that end, so basically we have here we are sending the request. On that side, we are processing that request, is going to actually start consuming the messages from the reactive stream, and then of course we can send it later towards the service layer and the repository layer connecting to the database, fetch the data from there. Once the data is being fetched from the database, we are going to send it, of course, back using another reactive stream, let's say a Flux again. We are going to send it back towards the stream observer, which now is called the response observer because we are sending the data back towards the client. Once it reaches that response observer, then again is being put on the HTTP2 channel and sent back towards the client. The client can, of course, subscribe, consume it, and do something with that data. Looking here a little bit, until now we saw how the design of gRPC is done. We saw when we can use it, but let's also look at some performance metrics, because this is also very important in order to take a decision if we actually want to use gRPC or not. So in this situation, we have a comparison between REST and gRPC. REST here was implementing using Spring Web, just normal as that. And gRPC was implemented using Quarkus in order to reduce the boilerplate that we actually needed to write. And we used here a message which had around 1,000 messages as a payload. And as you can see, if you are using a small payload, then the performance is super great for both the REST and the gRPC APIs. It's, I don't know, under 100 milliseconds, so it's pretty fast. But there, on a large payload, what we actually did was to send 4 million trades across the network, which is quite a lot. And as you can see, using the REST API, the messages were sent in around 1 second, 1.2 seconds, something like that. Whereas with gRPC, we actually managed to send back the messages in less than 200 milliseconds. So it's much, much faster. Of course, you need to take into account some things when you are building a gRPC API. Imagine that if you don't need to process anything on the server side, then of course you can fetch those messages and send them in one shot back towards the client, because that's more optimal, and we will see this later. But if, for example, let's say that you need to do a lot of processing on the server side for a certain request, then maybe streaming option might be better for you. Imagine that you get some data from another API, then you need to process it a lot, you need to enrich it, and then actually send it back towards the client. For that, if the client is actually able to consume the message as soon as possible, so as one message arrived, he can actually understand it and interpret it, then of course it's super okay to actually use streaming technique. If the client needs the entire data set in order to do something with that data, then it's better to actually construct a message which embeds all that data and send it back. Now, moving forward, let's look at a small comparison between them. JSON with REST can be compared with the Tron users. For those of you that watch Tron, you know that the users that actually connected to the grid, they are very human-centric, and they are there in order to build a better world, and they are super social, and they like to work with other humans. Whereas gRPC using Protobuf is more like the Tron programs, which actually are more oriented on performance and trying to achieve optimizations and trying to make all the life of the other APIs as good as possible. These are the gRPCs and Protobuf, because as we saw earlier, what actually they are doing is that we are not sending a text over the network, we are sending a byte away, which is something humans cannot understand by default. Because of that, basically, REST is much, much easier to debug. For gRPC, you need to build a lot of tooling around it. By default, you cannot understand the gRPC message as a human. So you need to have some debug tools in order to actually interpret those messages, look at them, see exactly what went wrong. In terms of the contract with REST, you can use tools like Swagger to document the APIs or to build something on top of them in order to maybe impose a contract between a client and the server from the message that you are going to use in terms of communication. While actually with gRPC, that contract is imposed by using the Protobufs. By default, without a Protobuf, you cannot build the gRPC API. So you have that Protobuf, you share it with the client, everybody is happy, you both understand the messages. In terms of message size, REST works with any message size without any problem. For gRPC, smaller messages are recommended because this is how you actually achieve the performance, as we also saw earlier when we described what are the caps. So as a small reminder, if you want to have the best performance, your message should be around 1 megabyte. If you still want to achieve some performance, you can go up to 64 megabytes or something around that, and you should never send a message which is bigger than 2 gigabytes. Now, let's do a little bit of live coding and see exactly how gRPC can be used and how we can actually leverage on it in order to build effective systems and reactive ones. I hope now this is going to be a little bit interesting. Is it big enough for everybody? Nice. I'm going to do it like this. I think it's better for you guys to see it. Nice. So here we have a proto definition. And on this proto definition, we can see here the message that we also saw in the presentation. This is how a message is being defined in Protobuf. Here, we are going to see another type of message which actually uses the repeated keyword in order to define that this is a list of the responses that we saw earlier. And we are going to use these ones in order to compare a little bit the performance. Looking a little bit on the code, we have just a small singleton that actually gives me back a list of 29 elements that we are going to use in order to test the performance. And this first method is actually using the stream of server and taking each message and sending it back towards the client. Whereas in the second method, as you can see here, what we are doing is to take all the message, put them in the proto that we saw earlier, and then sending only one response back. And looking a little bit at the performance, let's start the server, and let's also start the client, and let's comment this one. So first we are going to actually call with a list and then with a stream. The server started, let's also start the client, and you'll see the behavior that I described earlier. If it is, let's see how we can do it. Let's make it like this, and now you can see the result. So, the messages are inverted. Okay, funny. Here is actually with a stream. With a stream, it's much slower to actually read the data, whereas with a list, is actually read in less than 14 seconds. This is because we didn't do any processing on the server side. We actually just took them from a place, and we sent them back towards the client. Milliseconds, sorry. Sorry if I said seconds. Yeah, it's milliseconds. Now, looking on the proto, let's see exactly how we can implement a gRPC API. We see here the two definitions for the messages for the services that we saw earlier. Here we can see that Google offers us the empty protobuf in order to actually send nothing towards the server. This is mimicking like a get operation from the REST APIs. And now let's implement two other. Let's say this is an application where actually we can send data about a tail number of an airplane and get back the information about departure delay or arrival delay. So let's say that we want to build a report, and let's see per each airline network what are actually my delays for leaving the airport or arriving at another airport. For that, let's define a new protobuf, and we can call it like report entry. And here we can put the airline network as a response because we are going to need it. And here I'm putting a number. This basically says that when my proto message is going to be serialized, this is going to be the first field that is going to be put in the byte array. This is very important because a client actually could also interpret that protobuf based on the location of each field. As a good practice, is actually interesting to not use sequential numbers. So don't just increment them, because you can leave some space in order to actually have between the first field and the fifth field, let's say, you can have a slack where you can actually add new fields and perform some updates. So as a departure delay, let's put it a 5. And for a arrival delay, let's put it a 10. Doesn't matter. Of course, this is just for getting back the response. Let's also define how the RPC is going to look like, the service. So get report. Here, again, I'm not going to send anything. It doesn't matter for this one. And
is the byte array going to have the same size even though you incremented with +5?
Yes, it has some optimizations performed. No, but for example, if you have a very big message, like with 100 fields, then of course the size is going. Yeah. No. So
it's the same size.
Yeah. Now, this is going to return a stream back, and the stream is going to be composed of the report entries. And we will see later how this can be generated and how we can actually implement it. But we also talked about using bi-directional streams, which means that actually you have a channel open from the beginning, and then you can start sending messages and receive back responses. For that, let's also implement an API, because this is one of the strongest points of gRPC. Let's say that we want to make a request to get some data for a tail number. Let's build a request object, and let's just say tail number. And let's see how a service looks like. As you can see here, in order to say that the message that is going to send back is streamed, I actually use the stream keyword. Now, here, I'm going to also use the stream keyword when we are going to build a request, because we are also building a stream towards the server. So get data for tail number. Sorry. And I'm going to say, I'm going to send a stream of flight requests, and I'm going to receive back a stream of flight details response. So basically getting back the entire response for each tail number that I've sent. Now, let's compile the code and let's see what happens. In the POM, we actually have a plugin, which is Protobuf Maven plugin, that is being used in order to generate the Protobuf, based on the Protobuf, to generate the stubs, the Java code that we are going to use later in order to implement our APIs or to consume our APIs. Looking a little bit at what was generated, so the build was success. Looking at what was generated, we can actually see here that we have two types of classes. We have first, this is the class that is holding the implementation, it's holding the server details and how it's going to, what I need to implement in order to start sending the data. Of course, the same class can also be used on the client side in order to start consuming those messages. So this is the RPC part, the service part. We also have here some classes which actually, as you can see, represent the messages that we defined earlier. These messages also come in a pair with a builder that we can use in order to actually build our request and our response. Now, let's implement them. And I propose to start with the first one, where we are going to actually build the report. For this, let's override the methods. So here in this class, we are extending flight details gRPC, the implementation. And let's override the methods. And as you can see here, we have the two methods already generated, and we can actually extend them and implement them. Always look at the definition of the function. This is very important. So the first one actually doesn't receive anything and sends back something. And of course, it returns a void. Looking at the second one, which actually implements a bidirectional channel, you can see that we need to return a stream of server. Always look at what is the method signature. This is the key trick with gRPC. Based on this, you can understand exactly what you need to implement. So starting with the first one, I propose to you here to actually use reactive streams in order to implement it. And for that, let's get a flux. So of course, this is a flux with all the details that actually I read from. It's just a random CSV file containing around 20K rows of data, with exactly the data that you saw in the proto definition earlier. And with this flux, actually let's start building our report and sending it back towards the user. So of course, this report is going to show me exactly the data grouped by each airline. So we are going to use a group by function in order to group them by the airline network. Flight details response, get airline network, and now it's mapped. Looking a little bit further, actually in reactive streams, you need to start consuming the list in order to get the messages. So here I have like a flux of keys, which actually I can collect, and then I need to start building my response. And you will see that the response is pretty easy to build. So we have a report entry, which actually has a builder. Now we just need to set the airline network, and that's it. The airline network is actually, so because we group by the airline network, we just get the key. Now we need to build a departure delay. For this, I build a function. We don't need to waste time for this. And we are going to send, map, forgot to do something here. Flight list. What did I do? Just a second. So I did my flat map, I'm collecting it, and now I need to map it. And yeah, these IDs, I think it's better to actually use them like without any completion. We are getting dependent on them. Okay, flight list, and now we can actually start building it. Report entry, new builder, set airline network, and get the name, of course, departure delay. From the flight list, we are going to compute an average because I only want to get the average, and I'm going to use the flight list, and I have a function here which actually receives the lists and how we can actually map it, what is the field on which we are going to compute the average. And we are going to use flight detail response, get departure delay. Okay. And arrival delay, it's very similar to this one, so let's just copy paste it. But here, get arrival delay minutes. Once we build it, we actually need to do this, and we need to send it towards our consumer. So we need to subscribe. And now the subscribe method receives 3 things. For each reactive stream, we actually need to do something when we have an item to send, and we need to do something when we have an error. In case an error occurred, where is that error going to be sent? And each reactive stream actually has an error stream on which the errors are being published, and what I'm going to do when actually I'm completed with sending the data. So subscribing to it, I have the response observer, and I'm going to set that for each item, I will just simply call onNext. So taking that item, putting it on the stream. For each error, I'm going to put it on the error stream, and when I'm done, just call onCompleted and mark it as done. Now, given the fact that these are reactive streams, of course, we can also do something like on error, return a fallback, and then basically I might not even need the error stream, or I can say, okay, throw another error. Let's say that, I don't know, I'm processing some data and I have some sensitive information that I would not like to send to the client. Of course, I can also say on error, map it and throw something else in order for the client to actually not understand what, to not send sensitive information back to the client. I'm not gonna do that now, but it's very important for you to know that you can actually do this. On the client side, how are we going to implement on the client side the consumption of this? First of all, let's look a little bit at how we connect to a gRPC. So we need to build each time a channel. This channel is being built in order to connect to my local server, and it's using insecure channel credentials. For this presentation, doesn't matter, we don't talk about authentication and authorization, so I'm going to use a plain text channel, that's it. But of course, you can also implement authentication, authorization on top of it with a lot of other mechanisms. Looking on the method side here to implement it, let's implement it in an asynchronous way. On gRPC, we are going to see here that we actually have 2 types of stubs. We have a blocking stub, which is a synchronous one, and an async stub. Both of them are being constructed from the channel that I've showed you earlier. Now, for the first ones, we just use the blocking stub because we didn't care about that. But here we care about asynchronicity. So let's try to implement. Looking at the client side, we always want to start again from how the method definition actually looks like. And here we have, for example, get report. And we can see here that we don't need to send anything, and we are going to get back a stream observer. So let's try to call our method. of course, for the request, I can just say like this. And for the stream observer, let's actually build a response observer. And we are going to say like this. I want to build a stream observer out of a report entry. And I actually need to implement some of the methods here. So implement methods. And as you can see, I need to implement exactly on next, on error, and on completed. And I need to say what I want to do for each and one of them. On next, I'm going to say that, okay, I want to output something. Airline network. Yeah, it's just a typo. And departure delay and arrival delay. And let's pretty fast just get the information. Oh, yeah. Yeah, okay. And now on error side, let's simply do this. This is for completed. So when it's completed, let's just say that it's completed. And here we just have an error. Okay, good. Now we have the stream observer. We have it saved here in the response observer. And let's just call it. So this is how you can actually call it. Now, this is asynchronous, so I actually need an executor service to call it. I already have the call prepared here, but I wanted to show you from the beginning how you can actually know exactly what you need to send and how you can actually interpret the response. Restarting a little bit our server and going back in the client, and let's not see the output of these ones anymore. Let's just see the output of this one. Let's start it, run. It's a live demo, so let's expect things to fail. Ah, okay, they didn't fail. You know how it goes with the demos. Oh, sorry. So here, as you can see, we actually got back the response pretty fast. As an idea, I have around 20,000 records in my list, and the response got sent back pretty fast. Now, looking at the bi-directional one, because this is the most interesting one that we actually want to implement, let's look at the method signature once again. So, as you can see, I need to actually return a stream observer back. Here, what I actually need to send is the request observer. And let's try to build it. Flight request. As you can see here, I basically need to tell the client what he needs to send to me in order for me to be able to process that data. And let's take the information again. What we are going to implement here is just I'm receiving a tail number and I need to send informations about it. Get instance, get a large flight I think I also have, no, I don't have it, okay. And now what I want to do is actually create a map out of it, because I don't want to waste time to map, and we are going to say that we are going to map based on the tail, get tail number, and I'm going to, in the values, I'm going to just put exactly what I have. And in case I have some duplicates, let's just ignore them and actually just keep one of them. Okay, and this is my flights map. Okay, so what I'm going to do here is actually get my response observer, as I can see it here, and just send a response for each request. Get the data from the flight map, just get it like this, flight request. And in case I have an error, of course, let's just put a message. Oh, sorry. Okay, and when I'm completed, let's also put a message. And this is all the things that I need to do on the server side. Server side is pretty lightweight. I just only need to say my client, okay, this is how you are going to actually send to me my request, and I'm going to interpret it like this. Perfect. When I'm completed, actually I forgot here, I also need to mark it as completed, that I completed sending everything. Okay, perfect. Let's restart our server so we don't waste a lot of time. And on the client side, here comes the more interesting part, actually. Starting again from the method definition. Async stub and get data for tail number. Here, I see that I need to actually send exactly how me as a client I'm going to interpret the request that the response that I received from the server. And for that, we need to again define a response observer. Let's define the response observer. And let's say that we have a new stream observer. This is based on the flight detail response this time. Oh, and let's implement the method. Again, they are exactly the same methods. We are not going to waste time on these ones. So let's generate the code for showing the data. And also, let's see what we can do on error. Just say this. And now this is going to be also implemented asynchronous. So we have a latch. In case we have an error, let's count down the latch so we can know that something happened. Okay, and once everything is completed, of course, I'm going to count down the latch once again. Okay, good. Now, I need to actually get my request. So this one, let's say response observer. Okay, perfect. And let's call our method. And I'm receiving back, actually, a request observer. Let's see here. So let's do it like this, so we can see all the code. I've got back my request observer. And on this one, I need to actually feed it with messages. I'm going to do it here. I simply have a list here. Yeah, this is the list, which actually holds all the tail numbers that I have in my file. And I just want to call for each and one of them. I just want to get some information. So I'm going to say request observer on next. Just let's build a request, flight request, new builder, and let's set the tail number. Let's do it like this so everybody can see it. Set the tail number like tail number, build it, and send the request. Now the request is being sent, and we also need to say here request observer on completed. Here I need to mark that I actually completed sending all the data, and I need to actually process it. The server was restarted. Let's also restart the client. We will see a lot of output. Oh, I forgot to call the method. Live demo. Okay. Okay, it's 0 because probably I did a mistake on the server side. Let's see if we can identify it fast. If not, it's not that important for this. But the idea is to actually you guys see how bidirectional streams can be implemented. So I did it here. Flights map, get flight request. Probably the map is not okay. Okay. Nevertheless, let's continue. So we looked at how bidirectional channels can be implemented. We looked at how streaming can be implemented. I would like to emphasize again that you need to consider when you actually want to send data, you need to understand the fact that streaming is not every time the solution. Streaming should be used only in the situations that you want to do something asynchronous, or when actually the user can start consuming that message and do something with it as soon as he receives it. In case he actually needs the entire data set, then in that situation, you are better off actually building everything on the server side and then sending it towards the client. Going a little bit back at the presentation. Oh. And let me do this. Okay, regarding integrations, gRPC is integrated out of the box with frameworks like Quarkus and Micronaut, and these ones are actually pretty important to be used in case you want to achieve reactiveness. And what I didn't show you in the code, and I'm going to show you now, is how you actually build a gRPC server without any of these frameworks. It's pretty tedious, and you need to do a lot of things behind the scenes. With gRPC, you have a cost. You have good performance, but it takes a lot of time to actually do the coding part, because we only looked at the implementation side. But looking a little bit here, we can see that actually in order to implement a gRPC server using just plain Java and that's it, without any frameworks, you actually need to do some, let's call it low-level coding in order to start the Netty server, adding shutdown hooks and say, well, okay, what I'm going to do when the server shuts down, okay, how am I going to stop that server, so on and so forth. On the client side, again, let's look at how we actually called our server. We needed to create a channel, and we needed then to implement our stubs here and actually then call them. With those frameworks, with Micronaut and Quarkus, you can bypass everything, and Quarkus, for example, offers the possibility to just add a dependency and the server is spawned automatically. You don't need to do anything, and basically you can go directly towards writing the business logic that you actually need. With Micronaut, it's exactly the same. With Salesforce, what actually they did, they come on top of gRPC and actually implemented reactive streams. So gRPC uses the stream observer, you can use it. But as you saw, the code is not that nice. You still need to use anonymous functions, anonymous class. You still need to do a lot of boilerplate. With Salesforce reactive project, you can actually just have the code that is generated with fluxes directly or with the implementations from RxJava. And basically you have a method which looks like this. It's very funny how easy it is. So in this situation where you actually have get data for tail number, here is the bi-directional one, and it looks like this in that implementation. You have a flux of flight response, so it's the other way around, and then you have get data for tail number, and actually you receive a flux with flight detail request. Sorry. And this is your request. And you can just start processing it out of the box. So you see, this is the difference here. I actually needed to start building my stream observer. I need to do a lot of things. Of course, this is just simple code, but imagine that in a real life scenario, this on next is going to be much more complicated, probably calling 4 or 5 other classes behind the scenes. So yeah, with those frameworks, you can actually skip the boilerplate code. Reaching a little bit at the end of my presentation, let's think about the key takeaways that we actually have for this talk. Should we switch to gRPC or should we stay with REST? Well, the answer is pretty simple. It depends. If, for example, you build something like a backend for a front end, of course, REST, I think, is going to still be the go-to framework that the go-to paradigm that you are going to use. If you have a data-intensive application, or you need to have low latency, or you need to go towards real time, then of course gRPC might be better. When you go with gRPC, you also need to consider that it takes a little bit time for accommodating and to actually start coding in gRPC. I saw an article actually where with REST, as you know, if you just import Spring Web, you can just start implementing the REST controller, and you can directly just start coding. And that guy was saying that, okay, with REST, I can just do it in 5 minutes and I already have an API live. With gRPC, it took me like 30 minutes to do it in the first time. But of course, it's a trade-off because you spend a lot of time coding, but you actually have better performance. In terms of design, with gRPC, this idea of having a strong contract between the consumer and the producer is enforced by the Protobuf usage. Whereas with REST, you have a problem because, yeah, you don't have like a strong contract. Of course, you can build a lot of things in order to build that contract. You have Open API, which actually tells you how you should build APIs, what are the standards. Okay, you should have a schema which is defined from the beginning, and you need to share with your consumers. But yeah, gRPC imposes this out of the box. Of course, if you want to go reactive, we know that you can also go with REST, because you also have Spring Web Flux, which offers you reactiveness out of the box. But of course, again, as I've said, gRPC is not here to replace REST. It's just here to offer something more than what REST does, and it has different use cases. That would be it for me. Thank you very much. If you have questions. Yeah.
Your argumentation was that it leaves some buffer for us to add new fields. Wouldn't it be the same like if we did 1, 2, 3 and then add those fields at the end? Like, what's the real advantage of having that buffer?
The real advantage. So, for example, we use this inside our project to actually leave some buffers, because we have like a C++ client which actually does not rely on the name of the fields. He wants that in the first five fields, he actually wants to have certain piece of data. So that's why we are leaving a buffer. This is why we're doing it. Also, something else, you should know that these are all optional out of the box. they are not required. Of course, this is because we are using Proto 3 implementation. With Proto 2, you actually had the required keyword.
Do you use it internally?
Yes.
gRPC?
Yeah.
Between the microservices, or do you have it exposed to clients as well?
No, it's between microservices, and also we have C++ clients, and this is why we actually also went to.
It's a bit tough for the clients to implement on their client side something to communicate based on gRPC.
Well,
Way harder than with REST, for example.
yes, it depends what you understand by client. So on our side, we are actually producing a lot of data towards our consumers, and we see them as our clients. And for them, actually, this was driven from their side to actually start using gRPC because, as I've showed you earlier, it's very good in polyglot environments. And on our side, we don't have only Java. We also have C++ and other languages. And then, with C++, it was much easier to actually use gRPC. And because you have these stubs which are being generated, it gets a little bit easier. Any other questions?
One more question. How do you share the schema version between the microservices?
Yeah, this is an interesting question. For example, what we are doing at the moment is we are versioning it in Git. It's pretty rudimentary, and we are sharing it using a jar which is generated, and that jar is being shared with the Java clients. And what the C++ clients are doing, they are just getting the proto definition from the Git and generating with a plugin the code on their side. Of course, you can build on top of it something like a marketplace where you can actually upload the schemas, version them there, and
Probably have like another client, you get the data from there, and you just upload the like a repository and so on. You share it.
yeah, exactly.
Do you also version the gRPC APIs?
Yes, you can version them. This is something that we actually hit recently. With REST, you do it pretty easily because you put it in the URL /v1/v2. You can do it in multiple ways here with gRPC. You can just define another service. So let's say as you have this one, you can just take this one and say v2, and then of course you have another version. Or of course you can do it in the request. You can add a version field, and then you can, based on that, decide something. Yeah, there are multiple ways of doing it. Other questions? Yeah.
Question. Is it possible to do back pressure with gRPC?
Yes, so basically the stream observer comes out of the box with back pressure. And of course, you also have the reactive streams on top of them, which you can actually use. And also HTTP to channel offers back pressure. So everything can be done from the client side towards the server and back. We still have some time for questions if you have. Maybe another interesting question that popped up at some point was, how is gRPC being compared with Kafka? If you look at it, of course they are not the same and they should not be used interchangeably, let's say. But with the bidirectional channels, it still offers something like a pub sub or request reply mechanism. With Kafka also or with Pulsar, for example, which is also request reply. The idea is that is purely message driven and that's it. Whereas gRPC is more like, okay, I need to have a channel open permanently and just communicate on top of it and just reduce my latencies and so on and so forth.
Also, gRPC also has a constantly open channel from the client to the server.
Yes.
Okay.
So
It's
that,
like a WebSocket.
yeah, exactly.
WebSocket.
And basically, if you look at gRPC, we can do that actually. Every time you want to do a request, if you need to open a channel and you measure the time that it takes to open the channel and the time that actually it takes to do the request and receive the response, you'll see that most of the time is being used to open the channel. So yeah, that is a long-lived connection.
Is there a limit of how many open channels you can have on a client?
Yeah, this is an interesting one. Actually, from what I know, there is a small issue with the gRPC. If I remember correctly, it's around 100 channels that you can actually have open. The problem is that at the moment they don't have a channel pool. So yeah, this is actually a workaround, what you are saying, to open multiple channels and to then do the pooling on your end in order to actually start, if that channel is too full, to use another one, and so on and so forth. Okay, I think we have question. We have time for one last question if anybody has. Okay, then thank you very much. You are a great crowd. And if you want to talk more about the subject or about anything else, you can also find us on near the Platinum Room. We have a stand there, and I'm going to be there the entire day. So just drive by and let's discuss. Thank you.